All right, so our second day of transformations, we're going to look at two transformations. Okay, they're both pretty straightforward because as I just explained, the arithmetic is a lot easier today. And we're going to look at amplitude changes and vertical shifts. Okay, so first thing, first thing I just want to make sure we understand is what is the height mean? Okay, what is the height of a sine or cosine wave? Okay, well, when we talk about the height, the word they usually use is amplitude. Okay, and the amplitude measures the distance from, think of it as like the center line, to the highest point. Okay, that's the amplitude, which it's also symmetrical with the distance from the center line to the lowest point. Okay, so based on how I defined amplitude as a height or a distance, what do you think that means about amplitude? It has to be a certain kind of number. It has to be positive. Okay. And I think I write that down in a little bit. But when you're talking about the height, it's a distance. Distance is always positive. All right, so just like we did yesterday, the first thing we have to be able to recognize is if I give you an equation, how do you tell what kind of transformation it is? Okay, with a phase shift, it's when you're adding or subtracting in parentheses. Okay, we did that yesterday. With an amplitude change, it's when you multiply by a number in front. Okay, so for example, 3 sine x. That's an amplitude change. And the transformations we're going to do today would pretty much do what you would expect. If you put a 3 in front of the sine function, it's going to stretch it 3 times as big. Okay, what number would you have to put in front of it to compress it or make it smaller? We're going to talk about a negative. A negative does something a little different. But you'd have to put a fraction, yeah, like a half. Or like this last one, 1/2 sine x. We take the sine function and make it compress, make it half as high. When you put a negative number in front, well, there's two things that happen. Okay? If the negative wasn't there, it would just be taking the cosine function and making it twice as high. It would stretch it out. But putting a negative in front is going to do something else. Okay? Anybody know what putting a negative in front is going to cause to happen? Graham? So compressing is going to happen when you put a fraction. It's going to flip it. Okay? If you put a negative in front of something, what it's going to cause it to do is flip. All right? So in the first one and the third one, there's only one thing happening, either a compression or a stretch. In the second one, there's two things happening, a stretch and a flip. Okay? So as I mentioned earlier, if you want to know the absolute value, the amplitude of a function, you take the absolute value of the number in front. But if you want to know the amplitude of a function, it's the absolute value of the number in front. Okay, the reason we have to take the absolute value is because amplitude is the height. Height can't be negative. So putting a negative in has no effect on the amplitude. Okay? This second problem, if I asked you what the amplitude of this one is, or if I asked you for the amplitude of that one, it would be the same answer. The picture would look different, but the amplitude would not be different. Okay? So let's take a look at these and just see if we can get the amplitude, okay, for these three. What's the amplitude of 3 sine x? 3. How about the amplitude of negative 2 cosine x? 2. It would be 2. And the amplitude of 1/2 sine x? 1/2. And now what if I put a negative in front of it? It's still 1/2. So the negative didn't change the amplitude, but it would change the picture. But not the amplitude. Any questions on that? We're going to go through some sketches, and we'll do one that's with a negative so you can see how that works. Okay, so the number that you put in front of it, basically the big difference is, did you put in a number bigger than 1? Or did you put in a number that's a fraction between 0 and 1? Okay. If the absolute value of the number in front is bigger than 1, okay, that causes it to stretch. Okay. 6 would cause your graph to stretch. 10.4 would cause it to stretch. -5, that would also cause it to stretch. The negative would do something else, but the 5 part of it would stretch it. Okay. And then if you put a number in front that has an absolute value of less than 1, 1/2, that would compress it. Okay. 2/3, that would compress it. -1/4, that would also compress it. But the negative would also cause a flip at the same time. Okay, so any questions about if you put a number in front, whether it's going to cause your graph to stretch or whether it's going to cause it to compress? All right, so on the test, you're going to see some problems that are just like what we did right here. I'm not going to ask you to graph it. I'm just going to give you a function, and I'm going to say, what is the amplitude? So let's try one more. Let's say we had y equals 4 cosine x plus pi. What's the amplitude of that? 4. Yeah. The amplitude is 4. What's that plus pi? That's a phase shift. The plus pi is what we learned yesterday. It has nothing to do with an amplitude change. You can add all kinds of other numbers. Like I could put, we'll learn what that does in a little bit. It does something, but it has nothing to do with the amplitude. Okay? The only number that has anything to do with the amplitude is the one I just circled. That's all you have to look at. Okay? So that's an amplitude. The plus pi, for those that weren't here yesterday, that's what a phase shift looks like. Adding or subtracting a number outside the parentheses, nobody's seen that before. That'll be new, and that's the last thing we're going to do today. Okay. What about if I did this? What would be the amplitude now? Still 4. What if I did this? Still 4. Okay. All right, so next thing we have to figure out is we're going to take the points in our original table, and we're going to have to figure out where do those 5 points move to? What's changing? All right, so amplitude change. Okay, we're taking a graph, and let's put these back in phase, and we're doing something like this. What values are changing there as I move that slider? Yeah, it's the y values. Okay? Things are moving up and down. That's all that's happening. So, if the y values are what are changing, then it's the x's that are going to stay the same. Okay, so yesterday in the notes, there's an original table that I gave everybody. Okay. Actually, 2 original tables. One for sine, one for cosine. What you would do at this step is you would go back and look at that table, and you would write down the x's in that table.
Aren't the x's all the same on both graphs?
Yep. It just happens that the x's for sine and cosine are both the same. The y's are different. Okay, so we've got to be careful with that. Okay, so copy down the x's from the original table. And then to find the new y values, all you have to do is multiply the old y values by a. Okay, notice here I didn't write absolute value of a. You just take whatever number is in front. If it's a positive, it's positive. If it's negative, use it as a negative. Okay, when you're doing the graph, the negative is important. Okay, So just take whatever the number is in front and multiply the old y values by it. Do not take the absolute value when you're making the picture. Only time you take the absolute value is if I ask you a question just like that. What is the amplitude? Then you have to take absolute value. Okay, so we'll try one that stretches the graph out. We'll try one that compresses it. And we'll try one that flips it. Okay, any questions on those two steps or why the x's are staying the same this time and the y's are changing? Okay, this is both of the transformations we do today. The x's are going to stay the same. Both of them. Okay. All right, so let's see if we can graph 3 cosine x. Okay, first thing you have to do when you get the test is you're going to have to identify what kind of transformation is it. Okay, eventually, your 4 choices will be phase shift, amplitude change, period change, which we haven't done yet, and vertical shift, which we haven't done yet. Okay, so this is an amplitude change, but can anybody tell me how I know it's an amplitude change? It's in front of the cosine, and what else? There's no parentheses.
There's nothing after the x.
Okay, nothing after the x. What property are we doing with the 3 and the cosine? What operation? We're multiplying. That's the key. Because I could keep that number in front. I could do this, and that's a totally different problem if I put a plus sign in there. Okay, that's what we're going to talk about next. But the key is not only is the number in front, but it's multiplied. Okay, multiplied. And it's in front. Okay, so now we know it's an amplitude change. So James, when I do an amplitude change, what column stays the same? The x's. So we're going to copy the x's down from the original table. Marcos, do you remember what the original x's are from yesterday?
0, pi over 2, pi, 3 pi over 2, 2 pi.
Good. Okay. And now I'm going to write my original y values, but I'm not going to put them in the table. I'm going to write them off to the side, and then I'm going to fix them using that 3 somehow. Kristen, do you remember what my original y values are for cosine?
1, 0, -1, 0, 1.
Yep. Okay, so now we're going to take all those numbers we just wrote down for the y's. And Ariel, what am I going to do to all these numbers? I'm going to multiply by 3. And that's it. Once I do that out, that'll be the answer. Okay, so Gabe, if I multiply all these out, can you tell me what I'll get for y values?
3, 0, -3, 0, 3.
No, that's it. So that's why I said the arithmetic is a lot easier. You don't have to deal with fractions or anything like that. Okay, so I've got my table. 5 points for the x's, 5 points for the y. So you get 10 points for everything in that table. Any questions on how we did the table? All right, so the last thing we have to do is make a graph. All right, you've got a few choices how you set up your axes, especially on the y-axis. That's going to be 0. And I'm going to call that 3 and -3. I can number the y-axis however I want, as long as I'm consistent. If you actually want to draw all the lines in, like 1, 2, 3, -1, -2, -3, you can draw them in, but you don't need to. And for the x-axis, every single problem we do today, you're going to label like this. Pi over 2, pi, 3 pi over 2, 2 pi. These 4 numbers will never change for today. Okay, now just take your points and graph them. So we've got 0, 3. We've got pi over 2, 0. Pi is at -3. And then we're back at 0 and back to 3. Right, so that's typically how a cosine function looks. It kind of has that V shape to it because we're sketching that kind of that middle section of the wave that looks like a V. And so just kind of sketch that. Can't see through my own shadow. And it looks like that. And that's our graph. Any questions on that? Now, a lot of the graphs we do today are going to look the same. Okay? Because what I'm going to do is, instead of changing the picture, I'm going to change the scale. I'm going to change these two numbers, the 3 and the negative 3. Okay? Let's say you wanted me to do y equals 5 cosine x instead of 3. I could use this exact same picture and just go like this. And that's it. Now that's a graph of 5 cosine x. Okay, so all we're going to have to do is change our scale, and a lot of the pictures are going to look exactly the same in every problem. Any questions on that? It's just easier to do it that way rather than, like if you had to graph y equals 15 cosine x. It's easier than trying to draw something huge on your paper. Just change it to a 15 and a negative 15, and that's your scale. You went by 15s on the y-axis. Okay, and that's fine. Okay, so did this, compared to the original, is this a stretch, or did this compress it? It stretched it. This one goes as high as 3. What would the original one gone up to at its highest?
1.
It would have only gone to 1. Yep. So this has been stretched 3 times as much. Okay, what's going to happen here? Yep, how do you know it's not a phase shift, though?
Multiplied.
Multiplied where?
Front.
In front. We're also going to talk about multiplying next to the x. That'll be tomorrow. Okay, but this is multiplied in front. So it's an amplitude change, and specifically, this one's going to compress. Okay, so Henley, when I do an amplitude change, what column stays the same? The x's. Okay, and the x's for both sine and cosine are always 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, for those that weren't here yesterday, what are these numbers in degrees?
0, 90, 180, 270.
Yeah, it's just plus 90 each time. So you've picked 5 points that are all 90 degrees apart. We're just writing it in radians instead of degrees. Okay, now I need my y values for sine. Miles, do you have the y values for sine?
0, 1, 0, -1, 0.
Yep, perfect. So those are my y values. And now, Brianna, I'm going to take each one of those y values, and what am I going to do to all of them? Yeah, I'm going to take half of them. Okay, so do that out. And those are your y values. So Dave, can you tell me what my y values will be?
0, 1 half, 0, -1 half, 0.
0. Yep. Okay, I don't care where you show this work, or even if you just do the multiply by 1/2 in your head and you don't write it down. All that I'm grading is what's in that table. Okay. Okay, now last step, we're going to graph it. This time, what I could do on my y-axis is just go by 1/2. I could call this 1/2, and I could call that -1/2. If you don't want to do it that way, and you'd rather call this one a -1, then you could draw in a half yourself, right there. Okay, but the way I decided to do it is just call the top line a half and the bottom one -1/2. And that's 0. Okay, and Kelsey, for my x values, what am I going to put for those?
0,
Yep, 0.
pi over 2, pi, 3 pi over 2, 2 pi,
Yeah, you used to have to pick numbers that are equally spaced, and those are. They're all equally spaced by 90 degrees. We're pi over 2 radians. Okay, so we got 0, 0. Pi over 2, up at a half. Pi, we're back at 0. 3 pi over 2, about right there, and then back to 0. Okay, so compared to the original, did this one stretch or compress? Yep, this one compressed. Normally it would have gone to a height of 1. Now it only goes to a height of a half. Hey, any questions on that one? Okay, this point right here, the one that I just circled, that point is has a special name. And it's the one that's kind of in the middle here. But does anybody, especially if you were in the pre-cal last year, does anybody remember what that point is called? If you hadn't had pre-cal, I wouldn't expect you to know this name probably. But Dave or Graham, you guys remember? No? It's called an inflection point. It's an inflection point. Yeah. What's happening at that point is, if you look at the curve on the graph, I'm going to kind of try to exaggerate it a little bit. Let's say we had something like that. It's really kind of exaggerated. But what's happening right there is, before that point, in that section, which way is the graph opening? What I just traced in red. That part opens down. And then after that point, this section is opening what way? Up. Okay, so what's happening at that point is the curvature of the graph is changing. It's going from what we call concave down, okay, or opening down, and it's switching to concave up. It's opening up. And then when you go into the next section, it's going to do the same thing again right here. It's switching from concave up back to concave down, and then back to concave up. So what's happening right at that point is a switch in what they call concavity. That's the kind of a fancy name for that point. Any questions on that? All right. Not all graphs have an inflection point. Like if you draw a line, there's no inflection point in a line because a line is just straight. You got to look at graphs that are a little more complicated than lines to get inflection points. Parabolas, they don't have inflection points. They always open the same way. Okay? But if you start to get into a graph like this, there's a switch in concavity in there somewhere. Okay? At one point it's opening down, at another point it's opening up. Okay? So this is just one function that happens on, sine and cosine. There's many, many others. All right, let's look at this one. Now, this one doesn't have a number in front. At least I didn't write the number. But what number do you think is understood to be in front there? Yeah? Yeah, there's a 1, or in this case, actually, like a -1 in front of that cosine. So technically, we're multiplying by a number in front. But when you multiply by a -1, what's going to happen? So what's going to stay the same? Not the numbers. The numbers are going to change. But something about the graph is going to stay the same. The amplitude. Okay. This multiplying by a -1 will not change the amplitude. The amplitude is still going to be 1. But what's going to happen to the graph? Okay? It's going to flip. Okay? All the positives become negatives and the negatives become positives. Okay, so just like the last problem, your x's stay the same. Okay, we already have the original y values from cosine from an earlier problem we did. 1, 0, negative 1, 0, 1. And now I'm going to multiply all of those by negative 1. So we can get negative 1, 0, 1, 0, negative 1. So normally the cosine is like a V shape. Okay, that's the part that we sketch. This is going to be a V shape kind of flipped over. It's going to be more like an N shape. Okay, so I still am going to mark that 1 and negative 1. Pi over 2, pi, 3 pi over 2, 2 pi. Sometimes it's better to put your labels a little lower, so that way when you make your sketch, you don't draw through them. If you want to do that, you could just write your labels a little lower. Okay, so we've got negative 1, 0, 1, 0, and back to negative 1. Okay, so try to sketch it as smooth as you can. It just kind of comes in and goes like that. And this graph has 2 points of inflection, here and there. Because it would be going, this section that's only half drawn would be concave up, the one in the middle is concave down, and then it would be going back to concave up in that next section.
Do we need to know that? What that,
Do you need to know what that point's called?
what it does?
Point of inflection? No. No need to know that. Any questions on that? All right, so that's the amplitude change. And as far as the sound isn't overly interesting when you do an amplitude change. It just changes the volume. So we go from a louder sound, and then if I compress it, to more of a softer sound. Right? And then if you compress it enough, you can still hear it, but eventually, well, you're supposed to not be able to hear it at that point. Because it's compressed so much, it's basically just a straight line now. Okay. Any questions on that? All right, so now that we know how to do a phase shift and an amplitude change, okay, let me show you something. Okay, so here's a graph of just sine, okay, just the basic sine graph. Okay, and what I'm going to do is I'm going to graph, as a separate color in red, I'm going to graph negative sine x. What does the negative do again? It just causes the graph to flip. So basically you get that. Does anybody remember seeing that picture earlier, before we even studied amplitude change? We did that with a phase shift. Okay? I had that exact same picture in this program when I did it as a phase shift. So what that means is, if I were just to show you a picture, you might not know how I did that. There's more than one way to get this red line. Okay? Watch if I go like this. Okay? I'm going to graph sine of x plus, I think pi should do it. Okay? And you have to kind of watch it as it graphs it. What happened? It drew exactly the same thing as the red one. The green picture and the red picture are exactly the same picture, even though one is a phase shift and one was an amplitude change or a flip. All right? So in other words, there's more than one way to get the same picture. And there's tons of other ways, but those are the only two that I'm going to show you. All right, so the last one is a vertical shift. Okay, and a vertical shift is when you add or subtract a number onto the end of the function. Now, I thought a phase shift was when you add or subtract. How is this different than a phase shift? Yeah?
Not inside the parentheses.
Can you be specific about what is not inside the parentheses?
Plus or minus are not inside the parentheses on the outside.
So what if I did something like that?
Okay, the sine of whatever, or the cosine of plus or minus.
So the x and the number are not in parentheses. Okay? So in this case, normally you wouldn't put parentheses around it like that. You would see it written just like that. Okay, those are both examples of vertical shifts. Okay, what if I did this? Is that still a vertical shift, or did I change it to a phase shift? It's still a vertical shift. The only way it can be a phase shift is if you group the x and the 3 in parentheses. Okay, on the test, a lot of people try to do a problem like this as a phase shift, and they get all messed up. Okay, because it's not a phase shift. Okay, phase shift has to look like this. You've got x here, plus or minus, and then something inside it. Okay, so what do you think would happen if I did a plus 2? Do you think it would move the graph of sine up 2 or down 2? Up. Yeah, it does move it up. So I told you there were two transformations that do the opposite of what you would expect, and there's two transformations that do exactly what you would expect. Today, you just learned the two that do what you would expect. Amplitude change. Put a big number in front, makes your graph bigger. Vertical shift. Add a number onto the end of it, it shifts your graph up. Subtract a number, it shifts your graph down. Okay, that's what you would expect. With a phase shift, though, it was the opposite. At least when I think add, I normally think add would move things to the right. Nope, not with a phase shift. Adding moves things to the left. Subtracting moves things to the right. Okay, so if you weren't here yesterday, that's something kind of important with a phase shift. It does the opposite of what you would expect. Okay, so let's say I put this problem on a test, this one right here, and I asked you, what is the amplitude? 1. The amplitude is the number that's in front of the function. In this case, there wasn't a number, so you could just pretend it's a 1. How about the amplitude of cosine x minus 3? Still 1. Yep. There's no amplitude change in those problems. Okay. So last thing we need to be able to do to graph it is to identify where the 5 points in the original table move to. Okay, which column do you think is going to stay the same? It's not affected by moving things up or down. The x's. So it's just like a vertical, it's just like an amplitude change. The x's stay the same. Okay, it's the y's that are going to change. Okay, and to find your new y values, okay, all you have to do, okay, I'll put this right back up. You have to look at what you've added or subtracted, okay, onto the end of the function. Okay, like is it a plus 2 or is it a minus 3? Whatever number you have right here or here, you do that to all the y values. Okay, so if you have a plus 2 on the end, you're going to take all your y values and do a plus 2. If you got a minus 3, you're going to take all your y values and subtract 3. Okay, so again, arithmetic's very easy. You're just adding or subtracting a number from a 1, a 0, or a negative 1. There's no fractions here. There's no decimals. It's not like what we did yesterday. Okay, any questions on the two steps? Right, so we'll finish up with 2 examples. We'll do one that shifts up. We'll do another one that shifts down. And we'll try to do one with sine and one with cosine. All right, so we'll graph sine of x plus 2. Okay, first thing we always have to do, and same thing in the homework, make your table. Okay, Riley, what column in this table can I already fill in because it's not going to change? Yep, I can fill in my x's. And Sydney, can you tell me what my x's would be for sine?
0,
Yep.
pi over 2, pi, 3 pi over 2, and 2 pi.
Yep, perfect. Okay, so those are my x's. And Graham, what are my original y values for sine?
0, 1, 0, -1, 0.
Yep, those are the originals. I didn't put them in the table because those are not the final answers. Okay. And Kylie, what am I going to do to all those y values? I'm going to add 2. Okay, so add 2 to all those, and that's your answer. So Michael, can you tell me what I get when I do out that arithmetic?
You would get 2, 3, 2, -1.
Careful, -1 plus 2. It's like 2 minus 1.
So 1.
1, yep,
Then you get 3. -2, sorry.
2. Yeah, if you made a mistake on the table, hopefully you'd catch it when you graph it, because your graph would look kind of funny. All right, so now I'm going to label my y-axis. In this case, I can just go by ones, because I don't have to go any higher than 3. And my x-axis, using the same labels we've used all class. All right, so we're going to graph 2, 3, 2, 1, 2. Right on the marks I just did. So 2, 3, 2, 1, and back to 2. I know I'm off by 1. I can just shift them over. Okay, let's see. Is that right now? Yep. Okay, and just connect them. And that's the sine function shifted up 2 units. Any questions on that one? All right, so the last one, I think, I'll have you try that one on your own. Gabe, did you have a question?
No.
Oh, no. Okay, so the last one is y equals cosine x minus 5. Now, I put parentheses around the cosine x. What does that do? Nothing. Yeah, it means absolutely nothing. Unless I put parentheses around the x and the 5 together. Okay, if I did this, that totally changes the problem. Okay, so take a couple minutes and then see if you can graph example 5, or at least get the table, and then we'll go over it together. All right, so Kristen, can you tell me what kind of transformation is that?
Vertical shift.
Yep, how do you know it's a vertical shift and not the other one we learned, or the other two, phase shift or amplitude change?
Because the x and the number are in parentheses.
Yep, and what operation are you doing?
Subtraction.
Subtracting. Okay, so we got subtraction outside the parentheses. That tells you it's a vertical shift. Okay. Once we know that it's a vertical shift, that should tell us what column is going to stay the same. So Becky, what column stays the same? Yep, the x's. And can you tell me what my x's are?
0, pi over 2, pi, 3 pi over 2,
2 pi. And now we're going to take all the original y values. And Trevor, what am I going to do to all my original values?
Subtract 5.
Yeah, I'm going to subtract 5. Right, so Devin, did you get the y values once you subtract 5?
-4, -5, -6, -5, -4.
Yeah. Any questions on how to get those values? Those are correct. Okay. Last thing is, let's make our table. So we have to go as low as -6. Just like that. And I'm going to go same values on the x-axis as always. This time I'm going to put them up above so they're not in the grid. Pi over 2, pi, 3 pi over 2, 2 pi. Okay, we're at -4, -5, -6, 3 pi over 2, we're back to -5, and you should always end where you started. So there's your graph of cosine. Shifted down 5 units. Okay, any questions on that one? All right, so we've done 3 out of the 4 of the transformations. We did the phase shift, the vertical shift, amplitude change. The last one, and probably the most interesting one in terms of what I can do with sound, will be the period change. Okay? And that's stretching and compressing horizontally. So we'll finish up with that tomorrow. Okay, the homework tonight will be a worksheet. Okay, I'll make sure I put it in the video, so if you lose it, the problems will they'll be online as well.